Do you know what is this? Day 3 online classes 2020. Today you can see what I have drawn here. This is Cartesian product of sets with which we started our day 1. Then came relations, which we continued till last class, that was relations. And today we are in a topic which is called functions. Perhaps my favorite, functions. First of all, you can understand that not all Cartesian product of sets come into relations. There are many left out. When they form a relations, some relations make functions. That means every relation do not function. You check whether your relation is functioning or not. At the same time, I will tell you how do you identify that this relation is functioning or not. Okay, for that I will tell you one thing. I'll use arrow diagram. Okay, this is arrow diagram. You can check. um, Say if I have a set x, y, and z are its elements, and say it is a, b, c are the elements in this is set A and the other one is set B. Cartesian product of sets we can do A cross B, but right now I am making a relation among them. X related to A, Y related to B, and Z related to C. Then you can see that there is 1-1 correspondence. This kind of relation is called 1-1 relation. 1-1 relation. And this 1-1 relation is a function, remember, it is a function. And the best example for a 1-1 relation as a function is, you can think of many. One such is, you can draw any straight line. Okay, in the Cartesian plane, you can draw any straight line. Say this is the straight line which I am drawing. Okay, say L is the line. Now you can understand that since this line is y equals to mx plus c, or ax plus by plus c equal to 0, if you draw lines parallel to y axis like this, you can check that it intersects the function, that is the line itself, at only one point. Your this real line is your input, and the points where it intersects with y-axis is your output. Remember, these are outputs. So these inputs are called domain. All of you know domain, which we learned in class 11. And the output is range. Okay, and in between lies function. Domain is your input. This is input. Function will work on the input, and whatever it gives out, that is its range. So like in class 11 we had learned types of functions also. There are various types of functions. Right now I have given you a relation. The relation is 1-1 relation. I'll come back to that types of functions. I want to teach you that first of all, 1-1 relation is a function. Then there is one more relation which is a function, that is many to one. Many to one relation. Many to one relation, I can write this as, again showing by arrow diagram. Say A, B, small a, small b, C, D, E. Then say this is x and y. It is up to you. You can like interchange here and there. Suppose the input is A, I get x. Input is B, I get x. Input is D, I get y. Then E, then also y. Maybe C, input is again y. It depends on me, whatever I draw that will be shown, isn't it? But right now when the input is a and this arrow shows function, okay, so we can even write f of a as x, f of b as x, f of c as y, then f of d as y, and f of e is also y. Suppose there is one more element in the codomain set. This is codomain set. This is a domain set. Okay. In the codomain set, say there is one more element. Element is x, y, and g. There's z. Okay. Z is not mapped. No issues. Z is not mapped. Now, if it is not mapped, so you can understand that if this set A is your domain set, set B is your codomain set, there's a difference between range and codomain. Your range set has only x and y, whereas your codomain set has x, y, and z. Okay, there is always a confusion between codomain and range. Codomain is your set B, and your range is only those elements which are mapped in the set B. One more thing which I want to utilize is, whenever this thing happen, this x is your image. Image of what? It is the image of the pre-image A and B. A and B can be taken as object, but x is the image and its pre-image is A and B. Y is the image and its pre-image is C, D, E. So here we can write pre-image, P-R-E, pre, I-M-A-G, pre-image. These are also pre-image and this is image. This relation, many going to 1, is a many-one relation. And it is also function. Many-one relation is a function. Now I said one-one relation is a function, many-one relation is a function, but if there be a situation of a kind where what has happened, say, if my input is 1, 2, 3, okay, and my output is say x, y, z, okay, I put 1 in the function, I get x. I put 2 in the function, I get x. Now, two different objects have same image, that is, this is many to 1. Okay, so sorry, let me change a little. Okay, suppose I put f of 1, I get x. Again, if I put f of 1 only and say it is giving me z, then it is 1 to many relation. Obviously, 1 to many relation means not reliable, so it is not a function. It is not a function. Okay, so 1-1 relation is a function. I always take this thing in a different way. I always think that suppose this is a mirror in front of me, and if I see my image, obviously the reflection will give my image only, and someone from you also come and see, you will see your image, then mirror is functioning because it is 1-1 correspondence. But if it so happens that one by one all of us come and look into the mirror and all of us look like only one person, that is Salman Khan inside, we all must be happy that at least mirror is giving us one image and we can rely on this mirror and the image is Salman Khan. Fine. Or the relation of a kind like all of us follow one person, that is the Prime Minister of the country. Many are related to one. He is the Prime Minister of the country. If it so happens that every leader tells that I am the prime minister, then it is difficult for us to digest also, like to whom we follow. Mr. X from the like students who is like observing me right now thinks that my prime minister is so and so, and me, Mr. Y, will think like my prime minister is from some other, okay, say party. So in that way the country cannot run, so that relation is not functioning. So I will tell you, if the mirror is showing different faces and we cannot predict which face will come when a next person comes for its reflection, then such mirror is not functioning. It is not a function. Here also, if the input is 1 and the image is x, again the input is 1, the image is z, that means the same person is being given two different, like outputs. So that is why that particular machine which is giving us the output is not reliable, so it is not a function. Quote unquote, I can ask you right now that whether your relation is functioning or not, question mark. Okay, you can compare from here. um, in in this class 11 we were talking about domain and range, isn't it? Class 11 we were talking about domain and range. Let me come to few things like basics of a function before I go to types of functions. Okay, um, think of this, root under fx. I will leave this pen right now. Root over fx. Now tell me, under root of anything, can it be negative? No, it can never be negative. So it is always greater than equal to 0. Remember this. Always keep in mind. That is why in class 11, I hope you all must have practiced this question. Root over x square minus 4. It is greater than equal to 0. Always we take. If I have to find a domain and range, question mark, find domain and range, question number 1. Okay, if I am thinking of, then obviously in class 11 this was a hot question for everyone. So the way we used to start is, since it is a real function, again I'm I'm cornering you by saying this real functions. What is the meaning of real functions? Do you know? Real functions are those functions whose domain is a real number or it is a subset of real number. I'm saying domain is real number or subset of real number, then we say it is a real function. So if I want to find under root anything fx, it is always greater than or equal to 0. X square minus 4, so I'll take x square minus 4 is greater than or equal to 0. X plus 2, x minus 2 greater than or equal to 0. Then obviously this or that, we will get two critical points. This is minus 2, the other one is plus 2. Okay, and seeing the sign, it is the, sorry, seeing the exponent, that is the power is odd, so we can always think plus minus plus greater than equal to 0. I cannot take negative, I have to take positive. 2 to infinity minus infinity to 2. So domain of the function is what? Minus infinity to minus 2. Minus infinity cannot be in a closed bracket. Do remember this. And since it is equal to, I am using closed bracket, union 2 to infinity. 2 is again closed bracket, infinity. Closed bracket means minus 2 and 2 is also included in the domain. Okay. So this was the domain, and perhaps the range is, if you put all these values in this function, then whatever values comes out, that is the range. I think the answer is 0 to 2. Okay, so your domain is, you can put minus infinity to minus 2. Your answer will not be 0 to 2, it can be like more than that, because x square minus 4, if it is 4 minus x square, then we can think of the range can be 0 to 2. But if it is x square minus 4, the answer can be, like way above. It can be up to infinity also. Okay, I'm not going to that. So by putting these values, if I put in something a very large number, then obviously I will get square of that large number will be very large. Minus 4 is so small, so definitely the range will be, obviously it will be from 0 to infinity, I guess. 0 to infinity, 0 close bracket, infinity open bracket. Okay, so this was one such problem every time I used to see when I was talking with my students. Under root. Okay, the next one is, say, number 2, modulus function, mod of fx. Whenever you see mod of fx, say mod x, it is always greater than equal to 0. The function is always greater than equal to 0. So these are called, these are, like these functions are always positive. Then the third one is modulus function. Then third one is, say, 2 to the power x, 3 to the power x, 4 to the power x, and so on. X belongs to R. This is also non-negative, greater than 0. And it cannot be equal to 0, because 2 to the power x, you put any value of x, okay, from the reals, you will never get equal to 0. So there is a difference. Okay, it is equal to 0, 0 will also be attained, but here 0 will never be attained. Followed by 2 to the power. One more thing, see this one, x square, number 4, x square, x to the power 4, x to the power 6, and so on, x to the power 2n. N can have any value, okay, natural number you can take. So all these are also greater than or equal to 0. Okay, the always treat these things as this will always give us positive value. Okay, I'm again repeating: under root of any function, modulus, exponential function, and x square, x to the power 4, x to the power 6, and so on. There lies a problem with this quadratic equation also. I will tell